Let's talk about how to calculate the average atomic mass of isotopes. Before we talk about the calculation, let's go ahead and review the definition. Isotopes are just different forms of an element having the same number of protons but different number of neutrons. So when an element has a different number of neutrons, that really just means it has a different atomic mass. Let's take a look at the periodic table and let's focus on one of the elements. Let's focus on carbon. Now, carbon has 3 different isotopes, but all of the different forms have the same atomic number 6, which means that carbon has 6 protons. Now, they differ in neutrons because they have a different atomic mass, but what gets reported on the periodic table is the average atomic mass, and this periodic table is reporting 12.011 AMU for carbon. So what they did was they took the average of the 3 different isotopes and reported an average atomic mass unit. The problem with this formula is it's just not simply adding the 3 different AMUs and dividing by 3. We have to consider the percent abundance of each isotope. The formula for average atomic mass is going to be the mass of isotope 1 times the percent abundance of isotope 1. We're going to keep that information in 1 parentheses, plus the mass of isotope 2 times its percent abundance. And if we had 3 isotopes, then we would have 3 parentheses. If we had 4 isotopes, we would have 4 parentheses. Let's take a look at this first example. Calculate the average atomic mass of chlorine, which has 2 isotopes with the following properties. Chlorine 35 is 34.97 AMU, and its percent abundance is 75.78%. Chlorine 37, which is the second isotope, is 36.97 AMU, and its percent abundance is 24.22%. The first thing you want to do is write down your given. So my first isotope, which is chlorine 35, has 34.97 AMU, and its percent abundance is 75.78%. Chlorine 37 is 36.97 AMU, and its percent abundance is 24.22%. The first thing you want to notice is that the percent abundances of all of the isotopes should equal to 100%. So 75.78% plus 24.22% equals to 100. Once you have your given, you can now use the formula. But instead of writing my given information into the formula linear, I'm going to write them on top of each other so that my significant figures can be obvious. So, average the first one is going to be 34.97. Now, when we are going to multiply the percent, we can't technically multiply a number by a percent. We're going to have to convert the percentage to a number. So we're going to do that by dividing by 100 or just moving the decimal 2 places to the left. We're going to do the same thing for the second isotope. 36.97 is my mass times the percent abundance. Now for percent abundance, we're going to have to convert that to a number. So we're going to have to move the decimal 2 places to the left or divide by 100. Whatever you can remember is going to be okay. Okay. So this parentheses is equal to 26.500266. That's what the calculator is showing, so you don't have to shave off any numbers or try to estimate early on. You're going to round at the very last step of your problem. And 36.97 times 0.2422 is 8.954. Now, I want to, like I said, not estimate too early, but I want to keep a memory. I want to tell myself that the first parentheses would have produced 4 sig figs for a final answer. So I'm going to go ahead and underline my fourth significant figure. My second parentheses should have produced something with 4 significant figures. So I'm going to go ahead and underline my fourth significant figure. Now, the final step of this formula is to go ahead and add the sums. So when I add numbers, if I put this into the calculator, I'm going to get 35.454266. But I'm going to take a look at my underlined digits, and when I'm adding numbers, I'm looking at the one with the fewest decimal places. So this first number is giving me a number in the second decimal place, and the second number is giving me something in the third decimal place. So my final answer should have only 2 decimal places. I'm going to look at the number next to the underlined digit. If it's 5 or more, I give my underlined digit a score. So this is less than 5, so I'm going to keep it at rest. So my final answer is 35.45 AMU. Your units for average atomic mass is always going to be AMU. Let's take a look at another example. Calculate the average atomic mass of magnesium, which has 3 isotopes with the following properties. Magnesium 24 is 23.99 AMU. Its percent abundance is 78.99%. Magnesium 25 is 24.99 AMU, and its percent abundance is 10.00%. And magnesium 26 is 25.98 AMU. The first thing you want to do is go ahead and start off with your given. So magnesium 24 is 23.99 AMU, and its percent abundance is 78.99%. Magnesium 25 is 24.99 AMU, and its percent abundance is 10.00%, and magnesium 26 is 25.98 AMU, and they don't give us the percent abundance. But that's okay. So this is our given information. We know in order for us to use the formula, we have to have the mass and the percent abundance. Well, we know that the percent abundance of all the isotopes have to equal to 100. So I can go ahead and try to calculate the percent abundance of magnesium 26. 100 minus 78.99 minus 10.00 equals to 11.01%. So now I can go ahead and report a percent abundance for the third isotope. Now I have everything I need. I'm going to go ahead and set up my problem. Magnesium 24 is 23.99 times, this is a percent, so I'm going to have to convert that number divided by 100 or move the decimal 2 places to the left. And when I put this into the calculator, I get 18.949701. Magnesium 25, 24.99 times 10% is really 0.1000. When I put that in the calculator, I get 2.499. Magnesium 26 is 25.98 times, now I have the percent, I can go ahead and move the decimal. Now remember, I don't want to estimate just yet, but I want to keep a mental note. The first parentheses would be 4 sig figs, so I'm going to underline the 4th digit. The second parentheses, again, 4 sig figs, so I'm going to underline the 4th digit. 25.98 times 0.1101, that would be 4 sig figs. I'm going to underline the 4th digit. Now, I'm going to add up these numbers, and I'm going to get 24.309099. Now, when I'm adding numbers, I'm looking for the fewest decimal places. This one has 2 decimal places, so I'm going to round at the second decimal place. So my final answer is 24.31 AMU. Okay, I can go back and look at this and review. Notice that 24.31 AMU correlates to the isotope that has the highest percent abundance. That usually works out that way, and that makes sense to us. So good luck and keep practicing.